Welcome in to the Energy Tech Podcast presented by Atmos Energy. Today we have special guest Adrian Kane from Atmos International joining Mike in the booth to discuss from install to optimization, a masterclass in LDS implementation. Guys, welcome to Canonsburg.
Hey, Jeff. Yeah, man, this is going to be a great show. I am your co-host, Mike Flotis with the Energy Tech Podcast, live and right here in Canonsburg, Pennsylvania, as part of the Atmos Energy Control Room. And again, my host, Mr. Adrian Kane with Atmos International. Adrian, good to have you, man.
Thank you, Mike. Great to be here.
Yeah, glad to have you. You know, I mentioned earlier about you that you are there's a couple of terms that have been coined recently, and it's typically a masterclass or the mastermind. And I think you are definitely fitting the mastermind for leak detection just based on the number of years that you've been in the industry. And so Adrian's here to help us. You know, if you caught our first episode with Adrian, we began just talking a little bit about some of the things that we scared you a little bit about leak detection, and then moved into different LDS types that were out there and some of the challenges. And in this episode, we're going to go from an actual install to optimization, a real practical masterclass in leak detection system implementation with Adrian. And so we're really glad to have him here on the show. He brings lots of, like almost 3 decades of expertise. So we really appreciate it. And, you know, Atmos works with large customers, EMPs, anyone that's moving any hazardous liquid or has any time implemented their product is well aware of the capabilities of the team at Atmos. But, you know, Adrian, I want to ask you something because, you know, like I said, in my mind, you fit the mastermind of the industry in terms of leak detection. But what do you do? What do you personally do that when you're not doing leak detection, right? I mean, you know, when I was a kid, you always had teachers. We were all kids, and we always wondered, what do our teachers do when they're not teaching? So when you're not being the leak detection mastermind, man, what do you do?
Well, Mike, I like to play golf.
Do you?
So I play golf. I do a little bit of snowboarding, but these days I mostly seem to parent. So.
Oh, wow. All right.
Those 3 things.
Oh, wow. How many kids do you have?
I have one, which
Just
is
one?
plenty for me, an 8-year-old daughter.
8-year-old. Okay. Yeah. You got to get them when they're young, man, you know, and that's great, man, that you've got an 8-year-old. You know, fun fact, Adrian, I've got 8.
Wow.
I've had 8 8-year-olds. So speaking from experience, capture them when they're young is one of the biggest things. So that's really good to hear. Now, as a golfer, you know, I don't play much golf at all. I mean, what do you love about doing that when you're not doing leak detection?
It's great to get outside and into nature. And I like the whole mechanics of the golf swing. Yeah. And I've been playing golf since I was a kid, so you know I've been doing it a long time. But also I find it stops me thinking about leak detection and things like that, because if leak detection comes into my mind, I might miss the ball. Yeah. So you know it certainly helps.
Now I talked to you earlier, and of course I caught the accent and I couldn't tell if you were from Mexico or no. I'm just kidding. I think. You know, you mentioned a destination, which is Ireland, which, you know, for you is a special place. But you also mentioned golf there. What makes Ireland a bucket list item for golf?
So I think 75% of all the links courses in the world are in Scotland and Ireland.
Oh, really?
So we have a vast number. Also, golf courses per capita would be very high. Yeah. So we've got a lot of great golf courses. The Open was there recently in Portrush, which is very close to where I'm from. Yeah. So we got a lot of very challenging golf courses, and you know, a lot of the population play in Ireland. It's not a very bougie sort of thing to do in Ireland. It's just like a regular thing.
Okay, all right.
We got a decent course down the road here too called Oakmont, and that's where the U.S. Open was this year, and it really hurt some people. I don't know if you saw that. A lot of high numbers. So.
Yeah.
Wow. Yeah. So it sounds like terrain's a big deal, but I didn't know that about that. Like I said, I'm not a golf aficionado at all, but just to know that's the case, that's interesting. And part of interesting here is, Adrian, you know, you're going to kind of guide us in providing a practical guide, you know, a step a step-by-step guide, I think, in implementing and maintaining and optimizing leak detection systems. So the focus is moving away from just theory. Today, some folks got, you missed it, and it was a masterclass from Adrian himself here and in Canonsburg, where he did focus on moving from theory to a real-world execution, addressing common obstacles, and kind of looking toward the future of pipeline monitoring. So at this point, Adrian, if you caught our first episode, in this second one, I think here it's the point where if you're an operator, a producer, we'll say, and you've selected this, an LDS, you've secured a budget, now comes the hardest part, which is implementation. So kind of guide us through that, right? And then maybe we start with the project life cycle and kind of revealing some obstacles that you think are success secrets to achieving an operational excellence piece, for your LDS. So maybe if you want to walk us through that and get you started, man, I figured you can guide us.
Yeah, if you could pop that slide up there, please, Jeff. So one of the things that we like to do is to do the project very efficiently and very quickly. The reason being we want the pipeline operator to have leak detection as quickly as possible. So we try to do everything in parallel as much as possible. So right. One of the first things we do when we get going is our goal is to get the LDS installed and connected to the SCADA really quickly. And right. We aim to have that done within just a few weeks. And the reason for that is once we get it connected, we can either get leak detection going right away, although maybe not very sensitively, or we can just get it recording data, which is the main goal at this point in the project, because you want as much operational data as possible to tune, usually at least about 4 weeks.
Okay.
And then you get into a cycle where you're gathering data and tuning kind of on a repeat loop. And you can't move ahead of that because you can't tune any quicker than you can get data. So we really like to get into that part of the process first.
Right.
And then we can do a lot of stuff in parallel. So we do a lot of the project documentation while we're in that phase.
So I'm an operator. I've got started. If you look at that slide, you've got, where you're going to gather some information. And I'm believing that usually when something like that happens, we're talking about maybe, let's say I was looking at one of the products from your most popular product, your flagship product there with Atmos. Well, if I'm gathering information, Adrian, what does that look like for me? Is it just a list of tags that I dump over to you, or what does that kind of look like?
Yeah, one of the key parts is obviously the tag information and the SCADA information to make the connection, but we right. also are going to want to know lengths of the pipeline, diameter, okay. the fluid. I mean, this may be something we know pre-project also, so it can be very fast.
Right.
But generally, it's just the layout of the pipeline, then plus all the connection details.
Okay. So, yeah, and typically in that kind of relationship, you're usually working with, whether that's a SCADA or a pipeline group, someone in regulatory to kind of grab that information, which is a lot of times available pretty quick. So you can start this early part of the process, right?
Yeah.
Okay. You mentioned something, you're going to connect to SCADA, and, if someone is an operator, again, kind of putting myself in the shoes of the operator, the ops director, there's not a flavor of SCADA that you're waiting on. This is typically something you've worked with a lot of big platforms.
Yeah, I think we've probably worked with all the larger ones. Generally, when we're putting this type of product in, we're connecting to what's already there.
Right.
So the leak detection system itself will be using the existing instrumentation, flow meters, pressure sensors, and then also the control system. So we're very agnostic on control systems.
Okay. And
it's just a case of finding, whatever protocol is available, again, and existing, and we'll make that connection.
Okay. In my experience with the Atmos team and other EMPs where we've had this deployed, one of the things you mentioned earlier was tuning, which is a big part. You obviously want to learn, you're going to install the LDS, so you're going to basically build in your leak detection system configuration. You're going to install that leak detection system, and then you're going to connect to SCADA. And then you have this what we're going to call basically a loop, because you've got your data gathering, your testing, and then you're tuning this system. And it seems to be one of the most critical phases in terms of tuning. And what exactly is happening during tuning, Adrian, and why is it, or is this a phase where you can see success and failure for any operator?
Yes. The data gathering is it's the machine is recording the flow and pressure data as the pipelines are normally operated. So I think one of the key aspects to the tuning is to make sure that we're seeing regular information, the normal operation.
Right.
Is so where you might get a failure is, and it's only, I'd say, a temporary failure, is if you're just starting up the pipeline and it's not operating normally. So generally what that means is we're probably going to have to do a small retune a little later, whenever you hit the regular operation. Now what the tuning is you're setting, I mean, there's thousands of settings in a leak detection system.
Right.
So you're setting those to deal with instrument faults or just the peculiarities of the instrument. And then also just how the pipeline responds hydraulically and, to different operations. And even different operators can have slightly different ways of doing the same thing. So during tuning, you're just setting those sensitivity settings. You're setting many things, but the goal is to make the leak detection system as sensible as possible, as sensitive as possible, sorry, while avoiding false alarms.
So when an operator is, we'll say, in this tuning phase, I mentioned a minute ago that there's typically an area of success or failure for operators because it's a real critical piece of what you're doing. What do you think is the differentiator for someone that they put a system in and they have success, they put it in and I use the word failure, maybe that's the wrong kind of word, but ultimately they may not benefit wholly from their system, from the system. It's, to me, it's the best analogy I can give is, you don't see me getting on a Peloton, right? But if I got one, I might take time to develop a system, a workout. But if I don't do that and I spend too much time on Netflix, well, then I'm not using my system. But during a tuning phase, it might be I get used to it. I start developing that. And you mentioned earlier, sometimes it takes about 30 days, which is typical on tuning. What is the differentiator for success and failure in that case?
Well, the first thing that you find when we start tuning data is we start finding all the problems with instruments, especially if they've been in a long time.
Okay.
So very often we'll find an instrument, and it's just because we look at the data from a different point of view to say, a normal operator.
Right.
And the operator's just trying to move fluid safely and do things like that. But we're really looking at the quality of the data coming in. So at that point, we'll produce a long list of things that we would like looked at or fixed. And the operator can often look at that and go, I don't have time, or this is really a lot of work. It's at that point, if the changes we're requesting can be made,
right,
you can have a big improvement in terms of the outcome for sensitivity and things like that.
Okay, so let me get this right. So, and we worked with your team back in, Jeff, what year was that, 2015 maybe?
Yeah, around 2013, 14, 15 timeframe, we were pretty heavily engaged.
Okay, so we engaged with Atmos for one of the largest, what I'm going to call one of the largest leak detection projects at the time. It was very novel for EOG Resources. There in the it's the largest producer in the lower 48. There was an implementation there, and part of the success factors that I remembered when we did this project was number one, they had a great team on the SCADA side. If I look back now, I think, oh man, these guys were actually a very, very good team. Led by a guy named David Rodriguez on the Signet side, provided lots of detailed information. The measurement and automation group provided lots of detail with regard to pressure, and metering, and then the SCADA group. So there was some successful information, Adrian, that came out of that. And then the other success factors, I think, was in the way they, the approach you mentioned earlier, it was the way of thinking about this that even Atmos changed, and that's looking at this sort of like a node, a network, if you will. Instead of worrying too much about pipe, this was more about what are my total inlets and my outlets throughout the system, dividing it in key sections that make it optimal for leak detection. So other than what I've mentioned, do you think that maybe that played a big part in the success of their system?
So with that particular system, that was probably the first gathering network ever to have an advanced leak detection system on it. And because there's so many injections, and in the end we ran out to well over 100.
Right.
You have to treat the leak detection system a little differently. That you can't just look at flow scenarios where I flow from A to B to C or from C to A.
Right.
So we just started treating it more like a network. So what's going in versus what's going out. But I would think the other really big success factor there was just the ability to work with EOG's team, because when we first started that project, there was maybe only 20 injections.
Right.
And within a year and a half or 2 years, there was like 120. So they're coming on very quickly. And the work has to be done very quickly. So we need a really good coordination between the SCADA team and the Atmos team to make sure, because if you're late, you break the whole leak detection system.
Right.
So you have to be on time, and I think that's where we were all very successful on that project, and it's that very close collaboration.
Yeah. So, so I think that definitely made it successful, and just like you mentioned, I think the thinking was this network or nodal approach to leak detection. But on the flip side of that, Adrian, maybe you have one where we don't have to mention company names, but obviously there was maybe a failure, and maybe you have some key points about some where there was failure in that case and it wasn't as successful.
When I was earlier in my career, before I moved to the US, we did a lot of projects where they hadn't built the pipeline yet.
Wow.
So what happened was we got in these first phases of the diagram where we're gathering information, mostly writing documents. And you end up doing, 8 revisions of a functional design specification and 8 revisions of the initial LDS config. And then when you get the as-built drawings, the pipeline's completely different.
Right.
So that can cause a lot of problems. And then also they rush to do the testing. So they want to do the FAT before the pipeline even runs.
Wow.
So we put together simulated data for that. And of course, you don't see data faults or instrument peculiarities in it, which are, some of the main things that you're tuning for. So you don't have a real tune.
Right.
And then what happens is the test data is just not very good because you're not really testing the system. And you have to change it really a lot when you start to get real data. So I would say it's not very effective to do a project that way.
Wow. So what I'm hearing then is like testing is that big of a deal. And then the tuning process that comes as part of that. I mean, Jeff, if you kind of bring up that slide again, you'll see here. So you've got some testing and then you've got lots of training that's happening as well, right? That's going to happen. We're going to touch on that in a second in terms of the training side. But in between there, Adrian, you got some success, you've got some failure. Obviously, testing is crucial, for both operators, just so they can get their confidence, But in terms of testing during the project, what's happening just in the small testing pieces, right? Like what can an operator expect there?
So that's kind of why we give the training first. So before we do any testing, we'll train so that the operator knows what to expect and what to look for. And we write a very detailed testing document. So we go through all of the functionality within the LDS, show that it's all working.
Right.
And, it's a standard system, but it's also kind of an engineered system.
Okay.
So you do have to check that everything's working as it should. So we do a lot of functional testing at the factory acceptance test. But then during that, if you see I've got the testing after the tuning,
right?
We already have the real tuned system and the real data. So we can push leaks into that. And then we also do a bit of leak and performance testing.
Gotcha.
A little later on, when the customer's more ready, we'll do some site acceptance testing, which may involve real leaks or may not. It just depends on the pipeline and the customer. And at that point, we usually do a bit more training just to get more of the operators. So you need training to approve the testing, but then you want to do the training for the operators right when they're getting access to the system.
Yeah.
So we do that training too, and then maybe some super user training as well.
Yeah. You know, Jeff, if I remember correctly, back at the EOG days when we did the testing, I think there was an initiated leak into a tank, right? I can't remember, but I think that's what happened.
I think we used a couple different tests, and a needle valve was involved in one of them for sure. And we also utilized that time to do a drill, like an Open 90 style drill.
Yeah.
And we didn't tell the operators in the control room where this leak was. So it was all kind of hush-hush. If I remember right, it's been 10, 12 years ago, but we sent someone out into a portion of the pipeline. They installed a needle valve on maybe one of the pig launchers or close to, and we just kind of opened it up. And I sat in the control room and watched my guys kind of like look at each other and look around and I said, all right, guys, we're in the middle of a test. You know, like eventually I told them, like, especially when they started making phone calls, this is a test, this is a drill, right? And so I gave them the piece of paper. I said, read this as you make these phone calls, and that's kind of how we did it there. But yeah, it was needle valves, it was pig launching operations. I think we did go into a tank at one point too.
Yeah, we did.
So, and it wasn't needle valve on the ground, don't get me wrong. It
Right.
was needle valve into a tank too. So, but very small. We tried to, pinpoint that accuracy on that, and we were well tuned at that point, and we picked up every one of those, I believe.
Yeah, so that I think that what I wanted to point to there was that was critical, and to be clear, Adrian, you said, yeah, we want to test a real leak. We weren't leaking onto the ground.
Yes, right.
We, what this was a controlled test, but again, we had already learned, right, or we had already begun the tuning phase, and we took advantage of that time because we wanted the real world experience of the products. You were doing your Masterclass earlier today, and some of the folks in the class were like, hey, can we get a proof of concept out of the box and maybe try it? And I don't think I put Atmos in that category of, hey, this is like a Raspberry Pi and unbox it and set it up and there you go. Number one, I think leaks are too critical to put in that category. Second is this requires your advanced technique at Atmos and technologies that you can't just wrap it into a box and ship it to somebody and they'll get it on Amazon Prime. Right?
Well, to be honest, we would love to be able to do that.
Yeah.
We've certainly looked in. We've built lots of hardware that's just straps onto the outside of a pipeline.
Right.
And the goal was always just we sell you 2 of those, and
Sure.
you have leak detection out of the box. But unfortunately, it's a bit more complex than that. And
Sure.
we have so many settings to set that are based on things that you won't learn until the system's in.
Yeah.
So
Yeah, I
have
think
to
you're
do
right.
that. But I do want to say that the project process for most projects is 2 to 3 months. It's not
Yeah.
much longer than that. So
Yeah.
it's not like we're going to come back to you in 5 years and say, okay, now you have leak detection.
Right. Exactly. Yeah, it's a good point.
So let me ask you something, Adrian. You mentioned a client who was trying to get this thing ready for day one. And if you look at the DOT regs in 195, it's, as of recently, in the last few years, it's like, hey, if you open up this type of pipeline, you got to have leak detection. Kind of a gray area is kind of like you'd get to have it day one, right? But a system like yours takes time to tune. I'm assuming most auditors, if they show up and say, hey, did you have an LDS in place? Yeah, I've got my plan in place. It's going by RP 1130, which was provided by Atmos, et cetera. For a couple of weeks, maybe a month, we're in this tuning process, but I'm assuming that checks the box for most auditors. It's been a while since I've been through an audit on a liquid pipeline, but do you run into anything there? I mean, why was the client, obviously they weren't under PHMSA regulation because you said it was halfway around the world, but Does anyone ever bring that question to you?
Oh, yeah. It is very relevant. So a lot of the systems that we put in the U.S., the pipelines have been running for years. So that's just not really a question. But we did do a project in Canada earlier this year and a little bit in the last year where they did have a requirement from their regulator, not PHMSA, but the Canadian regulator, saying they did have to have leak detection from day one. So the difficulty with that is not so much the leak detection when it's running, it's the filling. So what they did was they filled it kind of from valve to valve, or maybe not quite valve to valve, but they would say we're going to fill section A today and B tomorrow. So what they did was then they would fill that section, and we were monitoring very closely kind of the barrels in, and we knew the volume and, you know, all of those things that we can simulate. And then they would do a shut-in, and then we can check very accurately if the pipeline's leaking. And then we go, you know, to the next fill period. But then when the pipeline is finished and it is fully running, at that point, there's a choice. We can either give you a slightly desensitized tune while we're doing the final tuning.
Right.
So it's not quite as sensitized as you would hope, but it's the best you can, well, it's not the best you can do. Or what you can do is you make the system very sensitive, but you put a lot of eyes on it. And that's what we did in this case. So we give them full sensitivity, and then we had a large team of our people looking at it and a large team of theirs. And we were making, you know, decisions based on what we were seeing.
Wow. So I want to go, you know, so Jeff focused a little bit on that regulatory, you know, gray a little bit, you know, to make sure that, yeah, we're in compliance, but we're in the process, right? They went out and bought their Peloton, right? They're learning, it's tuning. You know, what I want to know is, you know, right now, Adrian, you know, you got tons of connected environments, and two of the biggest things that seem to be coupled together right now, because so many operators and producers are wanting to run lean. You know, their budget-wise, there's a lot happening. And so two things come up. The first one is remote access, and the other is cybersecurity and its integration in their project lifecycle. How does Atmos address that in terms of, you know, products and things in relation to both remote access and cybersecurity?
Yes, cybersecurity is like an overarching thing. Like it's built into everything we do, from, you know, locking your laptop when you leave to physical security for our devices and things like that. And then good day-to-day practices, you know, like avoiding phishing scams and those sorts of things. So it's kind of all encompassing. We also do some work, and this is outside my subject area, but we do work to make the product as secure as possible.
Right. From
a cybersecurity point of view. Now, remote access is great because we can do the project very quickly remotely, which saves money for the client, and our engineers prefer it. But even more so, once the product is in and running, if the client needs some help, we can do it right away. So they're not waiting for us to get the site. Say we're on the North Slope in Alaska or something. It takes time to get there.
Right.
So the remote access is obviously a very important tool as part of the project. So if we're allowed remote access, we always follow the customer's method to that. So it will be a VPN. Each customer does it a little bit differently.
Sure.
The other thing is very important. There's no sharing of credentials or anything like that, so that it's all done very safely, and mostly I would say to the client standard.
Right. Yeah. Yeah. So you know, having worked with other producers and operators, I think, you know, I've run across different scenarios and different types. There's some that are easy, and you're right. There's some that are jump hosting, you know, from, you know, where your team might be. Maybe they're in California, or, you know, or they, you know, are in San Antonio, you know, or somewhere else. Then typically they'll follow the guidance of that operator, right, to get access. So I want to shift a little bit, kind of the human side of this, because, you know, one of the things I learned in not just DOG, but working with your team and Atmos in the past, is there's an effective, what we're going to call training period. And you just hit on this in the beginning. There's a training period in the middle of this process, even up through tuning. There's a training process. So you have some effective. What I like about Atmos is there's some effective training, even with alarm analysis and system diagnosis. So, you've said in the past that this is an important piece in having right procedures, or you want a customer to get it right. So what do you mean by that? Like, what is it you're getting at?
Well, so the whole point of having leak detection is for it to be effective. And it's effective when you get an alarm and you're sure it's a leak, you can shut the pipeline down or take whatever your procedures are and execute those to lower the risk for your company and to lower the damage should you be unfortunate enough to have a leak. So I would say that's probably the most important aspect. So what we try to do is, firstly, we'll train operators on the same thing repeatedly. So we kind of redo the same class.
Right.
And I often found earlier in my career, I was like, why am I showing this set of slides to this guy for the 5th time? But actually, that's probably the most effective way to learn that information. But on top of that, one of the things that we do a lot of is when we are analyzing the system for customers, either during tuning or in a warranty or maintenance period, we'll actually show them what we're looking at.
Right.
And we're saying, this is how we analyze it, and this is what we're seeing. And of course, we do have a more advanced, what we call super user training.
Right.
And that's what that is. That's hands-on. That's not really a classroom. And I feel that's one of the most effective ways to train at that more advanced level. That's not really a controller training. It's more for the internal expert.
Yeah. Yeah, I remember that. You guys have hosted us, myself, for some super user training. In fact, you guys what you really did was you went a step further and you modeled the system based on tag data that you had historically to do that. So that was even back then that was exciting. And then we're talking like 10 years ago, that you guys were doing this, to provide that kind of training. So along with that, you have some alarm analysis, super user or not, that, a lot of alarm analysis that happens, and you have a pretty decent, what I call your baseball analogy. So kind of share that with our group and explain why, periodic retraining is an important deal.
Well, the baseball analogy is simply that you may understand how to throw a baseball. And, you may, just as a human, know how to throw a ball, but also if you've had some training in high school or whatever level, they teach you how to throw a baseball very effectively.
Sure.
But you can have all the training you want, but if you don't practice throwing a baseball, you're not going to be a very good pitcher.
Right.
So you got to practice.
Yeah.
And, if you look at any sports star, the top stars, basketball, they shoot, hundreds of baskets a day. So with training, I think a lot of people, they undergo their leak detection training, and we show them how to do the analysis in particular, and then they don't do it for 6 months.
Right.
The thing about that is, if you're analyzing a leak alarm, it's a pressured scenario. You've got to decide, am I shutting down? Am I keeping going? Right. Am I following my procedures? Very high pressure. You don't want to be looking, where is this button? Where do I keep this trend? What does the top line mean? What does the bottom line mean?
Right.
So if you do a lot of practice, then that will become second nature to you. And one of the things that we do that I think, and we didn't do this when I first started, 20 plus years ago, but we've done it more recently, is we use the same colors on trends, and we put everything literally in the same place. So that you always know what you're looking at. So you could look at pipeline A or pipeline B, and you would still be getting the same data. You don't need to think, is flow, FIT 001, is that the inlet or is that the outlet? It's going to be the green one. Right.
Yeah. So you guys have moved to a standard requirement in how you've got that information laid out, which is a big deal. And I agree in terms of practice. In fact, even 10 years ago, you guys were doing, again, as a simulated training. If you couldn't, you're not trying to practice on a leak, right? Nobody wants to do that. But at the same time, there's some simulation there that can address a lot of that training to continue to comply and to continue to get better, even for the user type. And I think right now, Adrian, for the offsite control room, our goal is to high grade those operators. What I mean by that is the high graded role can belong to a production engineer, because we may work on the production side, and then you've got liquid lines, gathering and transmission lines and so on. My point is that you want to high grade an operator, and we want to get away from somebody that does not want to be in that practice. Jeff did a lot of Little League coaching. I mean, sure, he's got some bad stories, if when you don't practice. But the point I'm making is that in here, what should be common in any control room and leak detection especially, is that you want to initiate that practice and high grade operators for that, because those are the teams that take you to the Little League World Series, right?
Well, one of the great improvements we made since you guys were using the system is we've added in. We were always able to simulate leaks in the background, but that was us Atmos.
Yeah.
And we use that for FAT and sometimes for SAT. But one of the things that we've added is we have a test tool now that any operator can use. And that'll give you a leak size anywhere on your pipeline of any size you want. And then you can set it up to either give no alarms to the controller. So say you just want to test the system and not have the controller shut down the pipeline.
Right.
If that's your procedure. You can go ahead and do that in the background. You can also document that using the system itself and give that to the regulator, make that part of your 1130 package.
Right.
The other thing you can do is you can turn it on such that the operator can see it. And then you can also test their reaction to it. Are they following your procedures or not? So we've added that tool, and it's very, very effective.
Great. Yeah, so that kind of leads me to my next thing. You mentioned that in terms of training. I'm glad you said that, because part of that is proving compliance, right? There's training, there's other elements, but the next step is when it comes to kind of proving compliance, right? With the advent of 1130, APRP 1130, so in your mind, in your experience, what documentation is absolutely essential? Just thinking of, when I think of this, I think of training records, test records, logs, actions, tags, and then response to alarms, right? So kind of give us that, just a quick, hey, Mike, these are typically the most essential pieces anyway that you need.
The absolute number one thing is to actually read API 1130. Yeah. You'd be surprised how many haven't read it. There's three key sections to it. And the only way to be compliant is to, in fact, document all of them. Now, if you do a project with us during the project, we do documentation on the side or as part of the project in parallel. And I would say more than 50% of what you need is there.
Right.
In that documentation. But you also need all the things that you said, like you have to have records of who was trained, what they were trained on. You got to have test records that may be outside of the project, so like periodic testing that you've done. And then other things, PHMSA maybe are not asking for it much these days, but I think it's coming because they're asking for more and more, is documentation of what you did when you got a leak alarm.
Right.
I think that's the biggest part that's probably missing. Either that's not being shared with us, which may be possible, but or people are not doing it.
Right.
But certainly you need all of your test records. You should have some information about how you chose the leak detection system. You need your tag list for sure. And then you need to fill in, there's a whole section in Chapter 5 on things that are not the leak detection system, instrumentation, SCADA, data retention, things like that. So that is something we can sort of help you with, but it's not something we can supply because it's what you do, not what we have supplied to you.
Yeah, so it sounds, and that's one of the great things about Atmos is it's not so much just a product and a software. What you're talking about is being completely integrated with what the expectation for compliance is and what you can provide, and then explaining to a client customer, a producer, whoever, hey, these are sections you may want to pay attention to on your own in order to implement your program, right? It's kind of like, you mentioned earlier, in terms of baseball, you're pretty much coached. You've put together this program. You've given it over. It's up to that producer to practice and put these elements in practice. That Atmos will not provide. That's just a requirement of 1130 if you read the document.
Yeah, well, we also can't force our clients to do anything, right? But we can't say you must have a procedure and it must be this. We make a recommendation, and then you have to decide what to do based on your company and whatever risk you're prepared to take. So, and also you have to pair it up with operations. I mean, if you have a pipeline that's feeding a power station, and if you shut down the pipeline, you're shutting down power to half the grid.
Right.
That's a bigger deal than a pipeline in the middle of nowhere that's filling a tank.
Right.
So you really have to, it's not a one-size-fits-all.
Right. Yeah, that's a good point. And you right here at one-size-fits-all, sometimes that could be an obstacle that prevents companies from implementing their LDS in the first place. I'm sure, budgets is one, and the fear that, this task alone might be insurmountable, especially if you're like a mid-sized regional player or operator. In your mind, Adrian, what are some of the challenges that they might see that prevent them from even looking at a leak detection system in the first place? I realize that there's challenges like lack of power, instrumentation, multi-phase fluids is another one typically. But in your mind, I mean, give me some examples of some obstacles that prevent companies just from even considering an LDS.
Well, you always get the case where engineers tend to plan for the worst possible case.
Right.
So you could have, say, a dozen pipelines. On one of them might be a slops line with many different fluids. It's not really liquid filled. And yeah, it'll be multi-phase at that point. So that is a very difficult challenge for leak detection. But your other 11 lines might be almost perfect. So the idea behind it really is really just to get started. Don't fear the process. Just start the process and then do what you can, because at every single step you're reducing your risk.
Right. So having said that, Adrian, you in just risk reduction, some of the things you said here. You were doing the Masterclass early today, and you were I don't know if I liked it or I was 50-50 in here, because someone mentioned the fiber and acoustic system, and immediately you said that's the wrong system, just based on experience. So it was a very quick answer, and I liked it because it wasn't geared towards, you weren't selling anything. What you were doing was implementing years of experience in that one mention or question. So sometimes, even with Atmos products or other products, do you see kind of wrong system selections as an obstacle, along with maybe poor instrumentation that's out there?
Yes, the instrumentation too might dictate what the best solution is, but certainly for different types of pipelines, there will be systems that are better than others. Right. So in the case where you described from the Tuninig, we were talking about a gathering network that's very fluid. Everything's changing all the time. Right. And they're having a lot of external things that are happening that are affecting that leak detection system. Right. And it was an external system, and I think in that particular case, if you had an internal leak detection system, any of them, it's not being affected by things like trucks on the street and ATVs and all the other things that we talked about. So certainly if you can pick a leak detection system that's suitable for what you're trying to do, it helps. And one of the things I find is I guess our website, a lot of people get very excited about certain products when they see it.
Right.
The problem is they may pick the wrong one for the pipeline.
Yeah.
So it might be a great product for this use, but for what you are trying to do, we maybe should be using something else. And it's not just the leak detection system, it's very much the instruments, flow meters. I mean, a lot of people love to use ultrasonics.
Right.
And I get it. They're not flow wet. You can strap them on the outside. They're relatively cheap. And they work great on some fluids, but they're pretty terrible on other fluids.
Yes.
And they will ruin your leak detection program on those fluids.
Yeah.
So it's about picking the right one, not the cheap and easy one.
So those are not ideal for, let's say, accuracy's sake, right?
It's related a lot to the fluid.
Yeah.
If you have a fluid that's changing density a lot, they're going to struggle with that particular fluid just to the way they work physically.
Yeah. So that kind of leans into my next piece here is we're kind of looking ahead here on rupture compliance under regulations, typically like 417. So, you've noted kind of there's different, not just products, but when it comes to like mass balance, you can have, false alarming, some systems, expensive, but they're ineffective. You use the word effective. So kind of walk us through that a little bit in terms of rupture compliance. Like, are you suggesting, hey, Mike, sometimes these, an internal leak detection system, 9 times out of 10, this is the help?
So in 2022, they brought out this new regulation, 419 and 417, and it's 635, 636 for gas. And it says you must have leak detection to detect ruptures. And you must shut down within 30 minutes if you think you have a rupture. Now, I think that's a great idea. If you think you have a rupture, you should shut down maybe a bit quicker than 30 minutes. But what it is they have prescribed, firstly, a rupture is a 10% pressure drop in 15 minutes.
Right.
So what they are doing with that is they're prescribing that you use the simple pressure drop method for leak detection.
Right.
And they have defined what a rupture is. So when we looked at data from various pipelines, what we saw was that quite often, just during normal operation, you will get that definition of a rupture. So this is an example of regulators trying to improve things, but I think in some ways it's made it a little bit worse because those systems are going to be in alarm all the time.
Right.
Like we looked at different pipelines and you could see it and it's just normal operation. So there's a few things you can do there, but it's an example of not a great leak detection method for the majority of pipelines.
So what's a strategy then, Adrian, when you're combining that with an existing leak detection system? Like what's an important strategy then if you want to, have some level of, rupture compliance?
Well, you have to be compliant.
Right.
And if you want to, not have $1 billion leak potentially, you have to be effective. So the approach we took to it was we built another sort of bolt-on onto the top of our existing leak detection products.
Okay.
So we added in, and we did exactly what the regulation said. This takes an average pressure, detects a pressure drop within 15 minutes.
Right.
We record everything. We show when it's violating that, when it's not. That way, our clients, once they implement that, they're fully compliant. However, it will alarm a lot. So what we say is, since you already have a more effective leak detection system that is tuned to normal operation, so there's a caveat in this rule, and I'm sorry it's not on that slide, but there's a caveat that states unless it's normal operation.
I see.
So our more sophisticated systems are tuned for all normal operations, so they don't alarm during them. So it's fair to say that if you get a rupture alarm when you're reducing a pump speed, the more advanced leak detection system will say, yeah, that's normal. And it's also calculating that it's not a leak. But the rupture system may alarm. So what you can do is say, well, no, the normal system's covered.
Right.
So, but the point was we had to respond very quickly to our clients and make sure they were compliant. So we pushed out that module very quickly. And then the other big focus on it was to demonstrate compliance. So we made sure that we had good screens that could show exactly what we're doing.
Right.
And that could be used to justify changing, because again, there's another carve out where you can change some of those thresholds. So we made it such that it's easy to demonstrate that compliance, even if you change that. And that way you can show you're compliant, because the main difficulty with this particular regulation is that most advanced leak detection systems are not pressure drop.
Right.
So if you have a real-time transient model, or in fact even a negative pressure wave system, it's not doing exactly what the regulation is, and it's very hard to demonstrate it. I mean, you could argue it is doing it, but you couldn't demonstrate it with any ease.
Right. Well, that, kind of moving into that, away from even that, you mentioned a couple of requirements even for gas networks, and one of the interesting things about Atmos, or topics, one thing I want to touch on with you for a minute here is the simulation of gas networks. There are some, Atmos, I would say in the introduction of an online model, and how it's kind of implemented, how you enable advanced capabilities for these type of networks. Is there kind of a look ahead that Atmos has in regard to modeling and, intelligent optimization of gas?
So I think we're all waiting for leak detection regulations that are there for hazardous liquids to come to gases.
Okay.
So we end up always having the conversation about, does it work on gas? And the answer is yes. Most of the advanced systems will work just as well on gas as liquids. But once we start to get into the gas field, we find, especially if you're going to build a real-time transient model, which is one of the main ways for doing advanced leak detection, once you have that model, you can do much more with it.
Right.
Jeff, could you put up the last slide, please? Yeah, that one. Thank you. So what you try to do, so whenever you build a model, I mean, a lot of people in the industry are very familiar with hydraulic models. They use them to design the pipelines, operations, to size equipment, all of those things. But one of the more powerful things you can do with them is you can put them online. So you can connect them to various instruments, maybe not every instrument, but flows and pressures that are going to drive that model. And that is how you do leak detection with a real-time transient model. But once you have that, you actually have a really good digital twin.
Yeah.
And with that, you can start to look at, you can calculate everywhere on your pipeline, whether you have an instrument or not, what the pressure is. You can put on hydraulic profiles. You can make sure you're within the operational limits that you're trying to do. You can do much more powerful things like track the composition or the quality of the gas. You can do things like pig tracking or batch tracking on the liquid side. And then also you can look at what the capacity of a gas pipeline is, because you can store a lot of gas.
Yes.
And there's some really good cases like where the gas price out in West Texas was a negative number, so you're getting paid to take gas. And you could put it into your pipeline, I mean, if you had such an asset, and you could just keep it there for 3 or 4 days and then sell it in Houston for $3 or $4, per unit. And so you could actually make money on it. But it's very difficult to do that in real time if you don't have a good digital twin. So once you do have that digital twin, then you mentioned look-aheads. The next thing you can do, which is even more powerful, is you can take a snapshot of even a very complex gas network.
Right.
And that's coming from your live model. And it's telling you, the composition, the flows, the pressures at every point in the network. And you can use that as a jumping off point to go on and to analyze some future scenario that you're interested in, such as how much gas could I deliver in Houston next Tuesday?
Right.
And that way you can unlock more value from your assets.
Yeah, what I'm hearing from that is machine learning 101 right there, Adrian.
It is totally. It's machine learning and then AI. So one of the things that we have been working on is we're building an intelligent optimizer.
Yes.
And it's already deployed in a couple of places in the US. And what it's doing is it's looking at the entire gas network and it's trying to optimize based on certain rules that we've put into it. And it's looking at things like optimized compressor speeds if your goal is not to reduce the amount of fuel you're using. But you can also optimize it for almost anything else. Like, for example, packing gas in West Texas on Monday and delivering it in Houston the following Monday.
That's the monetization of your commodity using machine learning.
Exactly.
That's exactly what you're talking about here. And so, I think we're going to have Adrian on just to talk about that, Jeff, at some point.
Well, these guys, technically have been doing machine learning for 3 decades, right? I mean, the whole system, what blew my mind 12 years ago was, hey, this thing's not just being tuned by people, but it's learning every time it gets new data. And it learns what's normal. And then we can assume what's abnormal, but it also will learn what's abnormal because we can tell it, hey, this was an event, right?
Yeah, and you're right. And so I think that is something that Atmos has been doing successfully, with machine learning and data. And so one of the things you said in today's masterclass, Adrian, is that, people tend to recuse themselves or protect themselves by throwing words like, well, AI is going to do this, AI is going to do that. But from Atmos perspective, what I'm hearing is that you guys appreciate it, but you're like you've been doing for year over year is learning from it and implementing it where it counts. I think that's one of the steady things that I'm getting from Atmos.
Yeah, I mean, a lot of people are talking, we're going to use AI to do this, that, or the other. But when you're detecting leaks and you regulate it, you have to be able to describe how it's detecting the leaks. The AI can't just make it up and then maybe change it tomorrow. Right. Now, AI will certainly be useful for things like optimization and maybe some automatic tuning. Yeah, I think that might be useful within very strict limits. Correct. But I think rather than say, it's just AI, we base it on our actual experience and building effective, reliable systems.
Yeah, we also can't put that on the audit checklist. AI did that.
This is always about sound engineering principles or practices, right? And that's kind of what's built into Atmos over the years because you are the largest. You're on 2,100 systems worldwide. No one else has that data. It's just like Tesla, the car company, is really a data company. You've got that, and it's IP for you guys. So
that's a good point. So we're coming to a close here, Adrian. Trust me, I'd keep you here longer if we could. But I want to ask you something. So if you're a manager, an operations director, you're regulatory, EH&S, risk, this is your responsibility, which is a leak detection system. Kind of give us the top 3 things that an operator needs to do in order to have a successful LDS implementation and operation. Just those top 3 things that you think in your mind you want to share with a listener.
Well, the very first one is obviously to have a leak detection system that's effective for your pipeline and for your operation and for your company. So the initial analysis part is important. And then obviously getting that implemented is part of it. But once you have that, like once we got to the end of where I had the project complete, once you get there, you're only starting. Because your leak detection system needs to be effective every day to provide that risk reduction and the protection that it's providing you. So from that point, the next thing that's really important is to have really good procedures. So you need to have procedures for calibrating instruments and hopefully procedures for DOT pressure testing, which causes a lot of false alarms. If you have good procedures for that, but even more importantly, what to do when there's a leak. Do you shut down? Do you do an analysis? If you do shut down, who's allowed to restart the pipeline? What's the process? So it's having that, but again, you have to practice your pitching.
Yes.
So you got to practice that over and over again. Right. So that would be point 2. So the procedures and the practicing of them so that you do them. And then part 3 is documenting everything, because at the end of the day, you've invested in this asset to reduce your risk, but also to be compliant. So to do that, you should start the document process right at the start, right when you start looking at leak detection. And then it becomes, you set up all the initial parts, but there's parts you have to do every day. Like, are you analyzing alarms? Did you follow your procedures? Who was trained? So you need to keep doing that. And I mean, you can catch up certainly on some of it. So all the
Right.
initial part of the project, yeah, we can provide all that documentation. That's easy, but you don't want to get dinged for non-compliance when you actually are compliant.
Right.
So if you're going to buy the system, let's document it and demonstrate compliance.
Right. Those are some great points. We're going to come to a close here, coming from Mr. Adrian Kane. And I'm going to challenge him to be a regular contributor on this show, because this is a great example of leak detection being a big deal. And from the mastermind himself, Mr. Adrian Kane with Atmos International, glad to have you on the show. Appreciate you being here. Thanks a lot for joining us. And I am your co-host, Mike Flotis, with the Energy Tech Podcast. Don't forget to like and subscribe. Follow us. Great show.